In this video series, we are going to be examining the distance and the midpoint formulas, but before we get started in that, we want to first derive the distance formula. In order to do that, we need to recall the Pythagorean theorem. The Pythagorean theorem says the sum of the square of the legs of a right triangle is equal to the square of the hypotenuse. We know it as a squared plus b squared equals c squared. This theorem is crucial to deriving the distance formula. So let's first take a look at practicing using the Pythagorean theorem. So we're given the following side lengths and we're asked to find the missing side. So I'm given A is 5, B is 8, and I want to know C. So what I have is A squared, so 5 squared, plus B squared, 8 squared, gives me C squared. And so now I'm just going to simplify and solve. So I know 5 squared is 25, and I know that 8 squared is 64. So I'm going to be adding 25 and 64 to get 89. So 89 is C squared. And to solve for C, you would take the square root of both sides. And since we cannot simplify the square root of 89 anymore, we're just going to leave it as is, the square root of 89. So let's look at this one. We're told A is 4, so I have A squared. B I don't know, so I'm going to put plus B squared, gives me C squared, which is 12 squared. So A squared is 16, so I have 16 plus B squared. 12 squared is 144. So I would subtract 16 from both sides and get B squared is 128. And then I would take the square root of both sides to solve for B. And when I do that, I'm going to get B equals the square root of 128. Now, normally what we would do is we would focus on simplifying our radical like we've always have in the past. However, for this, let's just go and get the decimal approximation of 128, the square root of it, and that is 11.31. And so that is the value I will be looking for. So this is the Pythagorean theorem. The reason why this is helpful is because what you are doing with the Pythagorean theorem is you are finding the distance from this point to this vertex on the triangle. I am finding C, and C represents the distance from this vertex to this vertex on the right triangle. And so the way this helps us with the distance formula is if I want to find the distance from J to K, what I can do is first off label the coordinates. Now I'm not going to label the coordinates with the numbers. I'm going to label the coordinates with variables. And so this first point that I see, I'm going to label as x1, y1. The first x coordinate, x1, and the first y coordinate, y1. And so that's J. K, I'm going to label as x2, the second x coordinate, and y2, the second y coordinate. And I want to find the distance between these 2 points. So what I do is I create a right triangle. I draw, I'm going to use a dashed line, a horizontal line, until I get to where it would vertically intersect with K. And then I draw a vertical line. And since I drew a horizontal and a vertical, I know they're perpendicular to each other. So I just created a right triangle. So if you think about it, JK is my hypotenuse. That's my C. And so therefore, from J to this point would be A, and from this point to K would be B. The question is, well, how do I find those lengths? And what I need to do first is I need to state what the coordinate of this point is. That may seem like, well, you don't know because we don't have an x3, y3. We can't label it that. But take a look. Horizontally, I do not go up or down here. I went a straight horizontal line, so there was no up or down movement, which means my y value stayed the same. So the y coordinate at that point is going to be y1. When I drew the horizontal line, like I said, we focus horizontally. I did not move up or down, so my y coordinate is the same exact one as j. The same goes if we focus on the vertical line. The vertical line, I came straight down. I didn't move left or right. So the x value of k is going to be the same x value as this point, which would be x2. So this coordinate is x2, y1. Now we need to find the distance. And so to find the distance from J to this new point, and I can call it M or L or Q or P, let's call it L. To find the distance from J to L, what I would do, since it's straight up horizontal line, is I can subtract. I can take, to find the distance, this value of x2 and subtract the horizontal value of x1. And we can even look at the numbers themselves to kind of see that this is really the coordinate 2, 2. This is coordinate 8, 2. So 8 minus 2 does give me 6, which is this length, x2 minus x1. Since we're dealing with vertical here, we're not going to work with the x's, we're going to work with the y's. And so the vertical distances subtract y2 minus y1. And that will give us this length. And so if you think about the Pythagorean theorem here, Pythagorean theorem says a squared plus b squared equals c squared. What I can see from my picture is that a, the length of JL, is x2 minus x1. So a is the expression x2 minus x1. Now I need to square that. And I'm going to add b, which is y2 minus y1. And I'm going to square that. And that gives me c squared, which I'm going to let that be when we're trying to find our distance. So I'm going to use d for distance. So distance squared. Well, if I want to solve for distance, I have d squared. What I'm going to do is I'm going to take the square root of both sides. And therefore, the square root of x2 minus x1 squared plus y2 minus y1 squared equals the square root of d squared, which is d. My distance formula is derived. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And that is the proof of the distance formula. And you see how all it is the Pythagorean theorem using coordinates on the plane. So I hope you found that helpful with deriving the distance formula, with proving the distance formula. And we will now use that in some future examples to assist us with finding the distance between two coordinates.